Let's get this show on the road. So it gives me great pleasure to welcome Keziah from IBM. She's way over the other side of the planet on the west coast of America. So thank you for getting up so early. We do appreciate your time. We're really looking forward to your presentation on Db2 arrest. And despite the fact that this is the last session, I'm sure you won't have a rest today because it'll be an exciting and interesting session. So thank you very much, Keziah, sorry. And over to you.
Thank you. Yes, I'm happy to be here. And I am presenting today with Tori Felt. I think I saw her name. Marcus, I don't know if I can move her over or if you can. Let me check.
Yeah, I've just made a co-host.
Okay, wonderful. Thank you so much. So I will say hello and then I will turn off my video to prevent some distractions. So let me go ahead and start sharing my screen and we will get started. Oh. Of course, there it is. Oh. Oh, let's see. My Zoom is not letting me share my screen. Let me oh, there we go. And start presentation. Okay. And there we go. Now we are started. As Marcus said, my name is Keziah Knopp. I'm a Db2 for ZOS specialist out of the Washington Systems Center in the United States. And I'm here presenting today with Tori Felt. She is also a Db2 for ZOS specialist out of the Washington Systems Center. And we are both excited to be here. We will be talking about Db2 for ZOS and REST, as REST services and RESTful APIs. And before we get started today, I'm going to ask a poll question. You can just put your answer in the chat, but I want to see who all is in our audience today. So out of these roles, what role most closely aligns with your job? And if none of them fit, you can type in what fits best for you. I want this to be an interactive session, so please put things in the chat. You can answer my poll questions. You can ask other questions. You can make comments. I do have Mark Rader here as well, who will hopefully be monitoring the chat a little bit for me and can answer questions as well. If you'd like to pause and speak up and ask a question over audio, we can do that as well. And I see that we're getting some responses here in the chat. Yeah, A is system administrator, B is a database administrator, DBA, C is a sysprog, system programmer, D, application developer, or E, an other, if something fits better for you. I see we've got some DBAs in the crowd, some system programmers, DB2 system programmers. Okay, wonderful. Thank you all for participating, and you can keep putting your answers in the chat. I'm going to briefly go over the agenda. So today we are going to start by talking about mobile trends and the API economy. So this comes into play for where REST services, where you can see them in your real life, where they're applicable, where they're important, things like that. And that's what Tori is going to be covering here at the beginning. And then we'll move back to me and I will be talking about an overview of what RESTful APIs are, what they include, what does it mean to be truly RESTful. And then I'll go into Db2 for ZOS, REST services, how that's related to DB2 for ZOS, how you can create, discover, and invoke those. Depending on how much time we have, I may go into more detail or less detail on those, since we do only have an hour today. And then versioning for DB2 REST services is the newest feature. I have a fun example that we can walk through so you can see what versioning of those REST services look like, as well as a brief overview of ZOS Connect. ZOS Connect allows you to have truly RESTful services as opposed to REST services that are often used with DB2. So I will touch on that and kind of show how those can be paired for the wrapping up of this presentation. Okay, and I have one more question for you. So hopefully you finished answering the last one. And then I will pass this off to Tori. The question is, which of these do you have? I recognize that maybe I'm in the United States and some of these may be different where I am versus where other people are in other parts of the world. But if you have a smart home, this can be like a Google Home, an Alexa, an Echo, anything like that. If you have an Internet of Things devices, an IoT device, this is things like smart lights or temperature control or a smart lock or those video things where you can check your backyard to see if your dog is outside or something like that. Or if you use a mobile banking app even to manage your money. Or if you have a music player that goes across multiple devices like Spotify that can be on your phone and your laptop, or Apple Music. You can also have none of these. Just wanted to get a gauge if you've seen these, if you have these in your life, anything like that. I'll check the chat. Okay, we've got multiple answers here. All of them, A, B, C, D, great. C, D, wonderful. Okay, so it looks like you're familiar with some of these. That is good to hear. So we'll be touching on how these are relevant going forward. And on this next slide, I will pass this off to Tori.
All right, thank you so much, Keziah, and thank you for the introduction. Yes, this is great. I see we have a lot of people that have used at least one of these devices. I know I have many of these devices, but today we're really here to talk to you about mobile trends in the API economy and then going into some RESTful APIs in DB2. But the importance of the mobile trends in the API economy and talking about this is because so much of this relates to DB2 and the mainframe, because so much of customers' data and companies' data is on the mainframe. So we want to find ways to make it easily accessible. So going into some mobile trends, we have 5 main mobile trends that impact business decisions. So here you see a whole picture with starting off with mobile is primary. So over the past years, phones, tablets, computers, almost everything has evolved and revolved around these devices. And again, what does this mean in regards to enterprises and their data and their mainframe data? So the reason I'm talking about these trends is because we want to make these trends work with all the data that we have on Z. So I know for myself, I do keep my phone and laptop most of the time within arm's reach, almost 100% of the time. And if you think about, have you ever gone on a walk and you walk past a local grocery store, for example, and maybe you get an ad on your phone, on Instagram, or just somewhere on your search engine for that grocery store? Well, 75% of mobile shoppers take action after receiving a location-based message. And going into this part about mobile is about transacting. So for example, here we have Cyber Monday. We have Black Friday where you can go shopping, and then you have Cyber Monday where you can also go shopping online. So the whole idea here is just finding ways for companies to drive revenue and just create more ways for people to shop, not only in stores, but also from the ease of their home, therefore driving that revenue. mobile must create a continuous brand experience. So the idea here is that one of the main mobile trends that are impacting business decisions is being able to keep customers coming back and wanting to buy services or products. So, for example, one thing that comes to mind for me is, for example, an airline app, an application. So maybe you can book a flight online on your laptop, but you can also download that app for the airline and buy meals or upgrade seat purchases through the app. So it's just a way to have multiple screens come together and really just create integrated experiences. And then lastly, mobile enables the Internet of Things. So I know the Internet of Things is really increasing every day, and there's so many products out there that utilize this. But one thing I like to talk about is my parents' house, they have a freezer in their garage, and they basically use this freezer they buy a lot of their meat in bulk, so they can just have it whenever they want. So they keep it in this one freezer specifically. And one time I went home to visit my parents, and they were really upset because their freezer just randomly shut off and the temperatures just dropped. So all of their meat went bad. So they were very, very upset. But my dad went online and he found a product that he had me install into the freezer. And basically it's a device that will alert his cell phone if the freezer temperatures drop below a specific degrees. So if that were to ever happen again, my dad would know just by looking at his phone, oh, I need to go, something's wrong with the freezer, and it will be okay. So that's just one example of how we can use the Internet of Things today. And so again, our goal is making the data that's behind all of this accessible to people. But with that, there are many expectations of the cloud. So with this, people like the idea of connecting to whatever they want, whenever. Everything will be easy to develop. You won't be tied to a single solution. And there are also many misconceptions of Z, such that it doesn't support modern technologies, changes take too long, security seems foreign, and that Z doesn't integrate. So with all these mobile trends that I just talked about, a lot of people can expect that we can do all these things that we talked about in the cloud with on the cloud, but what people don't realize is that Z can actually be a part of this. And so in reality, the mainframe is actually developed today to be incorporated with the cloud. And then, so if you go to the next slide, please. So the reality is that Z actually does integrate, and our goal with creating APIs, which Keziah will be talking more about as well, is to make mainframe applications easily accessible through the cloud. So for example, connections to Swagger documentation allow APIs to be easily developed and connected to multiple programming languages. So it can reach more levels of programmers, and they can use the programming language of their choice. And we have other examples here, such as IBM API Connect, Explorer for ZOS. And these are just some examples of how modern ZOS is actually built around cloud development in order for developers to easily be able to use this. Business APIs are basically focused on providing an easy way to reach customers and consumers of the API that's being developed. And the goal here is to extend customer reach, increase revenue, and stimulate innovation. So when you think of a business API, one example that comes to mind is if you are signing onto a website, for example, if you're ordering groceries online, maybe you are prompted to sign in with an existing user ID and password, or you may be prompted to sign in using an email. For example, maybe Gmail. And so this example of Google sharing their data for a login API is one example of a business API. So basically, third-party developers don't have to create a login service from scratch. They can just import the API that was already created. In this case, logging in with your already existing email and password from your email account and not creating a whole new account. As you can see here, growth in web APIs really has significantly spiked, with total new APIs since 2015 above 8,000. And the main idea here is that yes, there are many more APIs becoming available, but it's the rate at which the APIs are increasing. So it started off a little steady there, but over the past few years, it's increased at a very high rate. And then looking at this page, so we just like to put this here to show how APIs can really impact revenue for large companies and industries. Percentage of revenue from public APIs for Expedia, for example, is 90%, eBay 60%, and Salesforce 50%. So business APIs really are generating a lot of revenue today. And so it's really important that we can stay on top of these trends and find ways for Db2 to be utilized in this area. And with that, I'm going to pass it back to Keziah, and she will now talk about more information on RESTful APIs in Db2.
Thank you, Tori. Let me advance. We have another question. So you're going to be interactive today for this last session. So what is your experience level with RESTful APIs? Before we get into it, if you are very familiar with it, if you've maybe worked with them before, but not a ton, maybe you've heard of REST services, you know those, that can count. Maybe you used APIs before, but maybe not necessarily RESTful or REST services, or this is the first time that you've ever been hearing about RESTful APIs or what they are. If you want to just, again, put the letter in the chat so we can kind of see who is in our audience today. Oh, it looks like we have a kind of a wide range of people. I do like talking with a diverse crowd, because as I kind of go into it, I'm hoping that I can introduce it and also gives new information at the same time to be applicable across the board. And I like to see where everyone is at. Okay. And thank you all for putting your answers in and participating. So while you're continuing to do that, I will move into RESTful APIs. We're going to go into an overview of what they are here. So what is a RESTful API? REST stands for Representational State Transfer. It is a type of architecture for sending and receiving data. And this type of architecture is stateless, meaning it does not have to keep track of any previous information or the current state of what it is. It just sends the information as it is in the moment, and there is no other information needed. It enables client-server relationships. So as this data is being sent back and forth, a client can receive information from the server, and a server can send out information to their clients. A cacheable communications protocol is used, meaning that the protocol can store information very briefly on one side. The particular protocol that is used is HTTP. That is Hypertext Transfer Protocol, and that is the same protocol that is used in the World Wide Web and general internet. A RESTful API, or API stands for Application Programming Interface. So this interface that you can use to program applications and send and receive this data and work with that. That API uses HTTP requests to get, put, post, and delete data. So those are those keywords that we will be seeing for RESTful APIs. And I have a quick note here that DB2 native REST only supports the post method for applications. So if you're creating an application using DB2 native REST services, you will be using the post method for those HTTP requests. Git can be used for some system functions, but not applications. And this is why DB2 native REST is REST, and ZOS Connect, which I will touch on at the end of this presentation, is RESTful because it can fully utilize all of those HTTP verbs. Okay, so some key principles of REST. So here on the left, the HTTP verbs, or create, read, update, and delete, CRUD, you may be familiar with that operation term, they map to the methods of get, post, put, and delete. So you'll be using those keywords with a URI, shown here on the right, where URI is a uniform resource identifier, very similar to a URL, like you're going into a web page. That has a host and port location, and then a path with parameters and these query parameters that define specifically what you are looking for within that host and port location. So when you are sending this URI, in this example, we use get, and we are going to acme.com. We are looking at customer number 12345, and we want to get the personal details. So with REST, we would put get and that URI there, and we would get a response of the information that we are looking for at that particular location. So here we've gotten a response with the ID 12345, the name, the address, all of the information that's at this location for this particular customer that we specified. And this brings me to REST and JSON, where REST and JSON are typically the interface and data payload format for the sending and receiving of information. So REST, as what we've been talking about, is looking at this URI. In this example, we are updating an account, and we will pair it with those HTTP verbs. And JSON is JavaScript object notation. That is how the data is returned. So once you are requesting a certain amount of information, the data will be returned in a name value pair format when you're using JSON. So this is really easy to read, and you can see here in this example, we are updating an account. So Smith is depositing $1,000 into his account. So some more examples with HTTP requests. So with this example, we are using the URL myhost.com, customer 235. So here is what it looks like for each of these terms. So get means that you are selecting the record for customer number 235. So if you pair get with that URL, you are just selecting it. You are getting that information. If you use put, you will pair it with some information to update the record for customer number 235. So in that last slide where we are updating Smith's account with $1,000, typically if you're using fully RESTful, that would be a good example for updating a particular record. Post plus new information is creating a new record in this example for customer number 235. So that pairs with the SQL term insert. And then delete, pretty self-explanatory. You would be deleting customer number 235. And SQL is structured query language, or SQL, however you want to pronounce it, these database language terms that we are using here. And again, I have the same note here on the right, that DB2 native REST can only use the post method for applications. However, you can pair the post method with these SQL terms, select, insert, update, delete, truncate with. So for example, if you want to delete customer number 235 and you are using DB2 native REST, you would post a method with the SQL term delete to delete that customer record. So why is REST so popular? Why do I have an entire presentation on it that I'm talking about right now? So the first reason here is that it is becoming increasingly common. It is helpful to use REST if you are trying to communicate with an external company or outside organization that also uses REST. So as REST becomes more and more common, it encourages even more companies, organizations, groups to use it. So if I want to send information out and get it back, and I'm using REST and JSON as we looked at, then that's easy for me to do if I know that someone else is going to also be using it and understand it from their end. It is relatively lightweight. So for communication protocols, REST is more lightweight than older ones, such as SOAP or WSCL, if you've heard of those. It is relatively lightweight. It doesn't have as much overhead as some of the older protocols do. This kind of relates to it being stateless. Again, where stateless means that with these client-server relationships for sending and receiving information, the client does not store, or the server does not store client information on the server side. So it only needs the information in that request that is being sent and received. It is also relatively easy for development. As we've kind of seen already, it uses URIs and URLs and JSON, those name value pair formats that are pretty easy to read. It's also built on this ubiquitous foundation of HTTP, that hypertext transfer protocol that is used for the World Wide Web and the broader internet, that is often already used for sending and receiving information. So that makes it easy to implement and to use going forward. So this brings me to DB2 for ZOS with REST services and how those work together. So DB2 for ZOS, we have some REST objectives here. So with using DB2 for ZOS, it uses REST and JSON to invoke one SQL statement or stored procedure at a time, at least. And it can enable new business value for your enterprise data. You're being able to send and receive this data in a very new way. You are modernizing using the power of SQL when you are able to use REST with DB2. It unleashes all of your DB2 data for the API economy. The examples that Tori was talking about when she mentioned the API economy and the business economy of being able to fully utilize your DB2 data to like increase your revenue and stimulate innovation and reach your customers. All of those things can be used when you're doing REST with DB2. So how does this all happen? What are some properties of DB2 REST services? So to invoke a DB2 REST service, it's actually directly through the DB2 distributed data facility. So you can access that using REST the same way. I have a diagram on the next slide that shows what that looks like from a broad overview. And some details of a service, where a service consists of one SQL statement or stored procedure call. So in one service, you will get one SQL statement or a stored procedure, where a service is a statically bound package in DB2. And that is opposed to a dynamically bound package where you can change things on the fly. So a statically bound package, you have everything in the bind state for that. And it can use call, delete, insert, select, truncate, update, and with. So those key terms that we've seen on this presentation already. Merge can be used in a service of a stored procedure, but not in a single SQL statement. Just a quick note for that one. And then you can also fully utilize all of the various DB2 based SQL data types. So this includes binary large object, character large object, double byte character large object, and XML files. All of those can be used here. So this brings me to a brief architecture diagram for what this looks like. So before using REST, you can access the distributed data facility inside of DB2 using things like Java database connectivity, Open Database connectivity, or .NET. And you would access DB2 through a particular port number. And then once inside DDF and in DB2, you can parse the data using direct relational database architecture. And now with REST services, you have your mobile application that has JSON data there, and you can access the DB2 inside of DB2, the DDF inside of DB2 using native REST through that same port number that you were already using before. And the data will be parsed using HTTPS for secure and JSON. And then once inside of DB2, you can act on that data as you normally would with authorization checks, thread creation, and SQL execution there. So when a developer goes to retrieve data, I'm going to talk about two personas that we have here. We have Max, the mobile app developer, and we have Devin, who is the DBA or the DB2 app developer. I recognize that in some shops, these two roles can be the same person, or they can be many people, or various combinations of that. But for this example, we'll be talking about them separately to see how they can be different. So Max, the mobile app developer, can invoke a DB2 REST service and look at the output that is returned in JSON format. The mobile app developer here does not need to know SQL necessarily, nor that the data came from DB2. They're just invoking that DB2 REST service and looking at the output. And we have Devin, the DBA or DB2 app developer, who can create a service that consists of a stored procedure or a SQL statement, or they can create or reuse that stored procedure or SQL statement in the REST call. And they do not need to know JSON. So that's a little bit different than Max, the mobile app developer. And how do we manage these DB2 REST services? There are three different ways that you can look at them within your DB2. So there is a REST client, a client in browser. This is typically a plugin where you can access the DB2 REST services through your browser and see what they're doing. We also have a REST app, a REST application. This is very similar to the browser interface, but it's just its own application. Or you can use the bind subcommand. If you are familiar with standard DB2 interactions, you can use bind to kind of manage those DB2 REST services if that is how you want to interact with that. So here is the DB2 REST service progression kind of paired with each of these roles of the mobile app developer and DBA or DB2 app developer. So discovering a service, you can look at it, see what's there. Both Max and Devin can do that. However, Devin has the authority to create a service and delete a service. And we are looking at Max as the mobile app developer, who can also display the service with Devin, but will really be the one executing that REST service. Okay, and I go into details, but for time's sake, I'm going to briefly touch on these. So discovering a service here, you just have to have the correct authority to do so. I will point out in this center procedure box, we have post with DB2 service discover. So that is that DB2 native REST service where we are using post with a particular URI to accomplish our task. For fully RESTful, you can use Git, and you're looking at the services here. So that's how those are a little different. And you can just use that URL to discover those. And when you are discovering a service, the successful completion code is 201, which is an HTTP code that you will get. Creating a service, again, you have to have the correct authority for this. You will be posting because you are creating a service, whether you're using REST services or RESTful APIs. And you can specify what you want in the body with a JSON format that's shown here in the center, where you're creating a service and giving the rest of the information that is needed here. You can also create a service using JCL. Here's what it looks like. This is in the ZOS Explorer Eclipse-based interface. Yes, this is the ZOS Explorer one, but it would be the same if you're doing JCL, submitting a JCL batch job through a TSO interface as well. Okay, so that brings me to display, execute, and delete, and I have a link here that links to the rest of the details of this documentation for what displaying, executing, and deleting a service can look like. They follow a very similar format as what we just saw. Okay, and here is some information for troubleshooting REST services. Again, I won't walk through all of these, but these are HTTP codes that kind of give you some information on where an error may occur, whether it's on the server side, the client side, or something else. Again, there's a link here that you can look at all of these status codes if you would like for HTTP requests. So I will move into versioning for DB2 REST services. This came out with an APAR recently, PI 98649. So this is a fun new feature where versions of REST services allow for the development and deployment of new versions of REST services while existing versions are still being used. So this versioning is built on existing package versioning support that is already there. You will use the same authorizations similar to the DBA and the mobile app developer that we looked like for versioning, and you can specify a version ID for a particular REST service or accept the default of v1 if you'd like. And you can also now select the default version of a service. So if you have multiple versions, that you have a service that is v1, v2, v3, and you want v3 to be the default version since that is the most up to date, you can do that. And for versioning, here is the URI format that we're looking at. So this is the original in the top where we have the services, you would specify a collection ID, those brackets there mean that it's optional, and then you have your service name. And now with versioning, you have to have the collection ID that is no longer optional, and you have that version ID number that is tacked on to the end of the URI, which the default is v1, you can specify it to be whatever you'd like, and that is optional since you will have a default. Okay, so I'm going to quickly walk through an example of what versioning may look like in a mobile application. So let's say this is your work phone and you are looking at what other employees are in your company. So this particular service, we have IBM services display employee. This is a created version where you can view the employee that you're searching for. And then let's say you enable versioning. And then once versioning has been enabled, you create a new service. You create select by employee number. So here on the right, we see that Christine is employee number 10, and that is version 1 of this service. And then as you're creating this, you realize that you may need to know who the manager is for this employee that you're looking at. So you create a second version of select by employee number, select by imp num, where you include the manager as well as the employee number and the employee. So now this is what we're looking at. And then let's say you want to give Christine really great feedback and you want to give her manager a call. So let's include the manager phone number as well in this select by employee number. So now you have version 3 of select by imp num that includes the manager phone number, and the original information for the employee. So instead of having 3 different services where we have select by employee with manager, select by employee with manager and manager phone number, we just have version 3 of select by employee number. So for enabling DB2 REST services with versioning, you just apply the APAR that's associated, and you can enable versioning by running the sample job dsn tijr2. Pretty easy to set up. And so some features of versioning is that there is no impact to pre-existing versionless REST services. So those exist as they had been before if versioning is enabled. And there is an empty string value in the version ID for those versionless REST services. So where that v1 was, it would just be a string. And then the services that are created after enablement of versioning are always versioned. So they will always have like the default of, v1, v2, v3 that we looked at, or whatever you would like to specify in that versioning ID placeholder. So overall, this simplifies the modification of services. As we just saw in that example, instead of having to create multiple different services to kind of do the same thing of what we want, we can have just that one service and call the version that we're looking for. This overall improves time to market, increasing the speed at which you can use and access the REST services in the way that you want to. Okay, I know we're going through this quickly, so I'm trying to keep an eye on time, but I want to briefly talk about ZOS Connect, because ZOS Connect is a tool that we use to kind of modernize and transform even more so beyond what we do with DB2 native REST services. So ZOS Connect provides a single point of entry for ZOS resources that are in the cloud via fully RESTful APIs. So here on the left, we have our user, and this consists of a single configuration administration, single security administration, and it does the mapping of these really RESTful APIs to existing mainframe and services data without having to write any code. So this ZOS Connect goes in through whatever ZOS you have and accesses DB2 or really any of the other subsystems that are listed here. And ZOS Connect consists of two parts. There is a runtime server, which hosts these APIs that you've defined to run. It connects with back-end systems, and it also allows for multiple instances of ZOS Connect to exist at the same time, so you can access multiple things with multiple instances of ZOS Connect. And the second part of ZOS Connect is this tooling platform. It is Eclipse-based, and this is where you can define APIs, define the data mapping with these REST services to access the data that you're looking for in ZOS. You can deploy APIs to a runtime server here. You can create an open API document and then export these APIs for other tools to fully utilize and deploy. So looking at data mapping, so here we have our user on the right, or programmer even, trying to access particular data in a Z subsystem on the right. And using ZOS Connect and REST services, we will put in this request. So here we have that same GET example that we saw earlier in this presentation, acme.com, looking for customer number 12345. And ZOS Connect will take that, will identify that ID and do this data mapping into a COBOL copybook, let's say, and then access the backend ZOS subsystem, and then return the information that is being requested in that RESTful API or that REST service and present it in JSON format. So it does all of that mapping and translation behind the scenes without you having to write any code or do anything. It will do it automatically for you. So this uses developer-friendly APIs, and the applications on the back end are unchanged. So that can be really helpful to fully utilize your existing subsystems on Z. And so here we have DB2 REST services with ZOS Connect kind of doing this connection, making this connection here, where DB2 users can create native REST services, and those are invoked only by the post method. Those are the notes that I've been mentioning throughout this presentation. However, a lot of mobile and cloud and app developers and programmers use the fully RESTful API design model where you can have access to the HTTP methods of post, get, put, and delete, things like that. And so ZOS Connect, this tool maps the DB2 post method SQL statement to the appropriate RESTful method for a given behavior that we're looking for. So here's this same architecture diagram. Hopefully this looks familiar in what you've seen before, where now we have this ZOS Connect here. From our mobile application, we can go through a RESTful API into ZOS Connect, where ZOS Connect will do that translation to a REST service and then access DB2 with the distributed data facility where that data can be parsed just the same as it was before with native REST and with the prior access before REST services. So we have a couple of customer examples that have used REST services. Again, there was a large US manufacturer, since I'm in the US, and the company needed a simple portal to navigate DB2 for ZOS. They needed an easy point to access DB2 and see what was there and kind of have it easy to understand if they were bringing new people in. So the solution was a DB2 native REST service was used to create a web browser UI and a tool for interacting with DB2 for ZOS. So this allowed all of the DBAs, both new and experienced, to access this interface on the web and could smoothly navigate around DB2 for ZOS using an interface that they are already familiar with. So that made it a lot easier to get the information they're looking for, to read, and to act on what they needed to within DB2. And another one, so there are a lot of words here, but I'll give a general idea of what happened. So there was a large automotive company also in the US that wanted to rapidly automate their manual process for loan extensions. So this actually happened in March 2020, when all of the craziness happened with COVID-19 and the start of a global pandemic, and a lot of their customers were requesting loan extensions. And they previously, up until that point, had had a manual process for this. And they had this massive increase. I think they had 19,000 per day, these requests for these extensions. So the solution from IBM came in with ZOS Connect to generate fully RESTful APIs. This also paired with Kubernetes and microservices and a few other things that allowed this to fully happen. But these ZOS Connect APIs were leveraged to rapidly innovate and automate the process for these loan extensions. So this became all automated and digital. So if a customer came in and they were requesting a loan extension and it was, March or April of 2020, they were accepting all of these. So that just happened so much more quickly. Their customers were a lot more satisfied with that process, and they got the information that, okay, my loan is extended, I can wait for right now. So that is huge. Okay, and that actually brings me to the end. I was worried about time, but here is this final session feedback. Please give feedback on this session and all of the other ones that you've done today. This is session 2E. You can scan the QR code. I've been told it takes you directly there. And here's my email as well as Tori's. If you have any questions or comments about this presentation, about DB2 for ZOS, about REST services and RESTful APIs, please don't hesitate to reach out. And I will pause here if there are any questions and check the chat as well.
I see Mark has been fielding some of the questions. Thanks
Thank
very
you.
much, Mark. Very useful, very helpful. But I'd just like to thank Keziah and Tori for a fantastic presentation. What a great team you make. Very good, like bouncing off each other. Excellent. Really interesting, very engaging. And yeah, I hope to hear more of you, both of you, on in the days to come, tomorrow and the day after. So we're looking forward to your other presentations and to
Thank you
as well. Once again, thank you very much for listening. Session is 2E. Please put your feedback in. It helps us to curate and make good presentations for future conferences. Any questions? Well, it looks like that's it. Thank you very much, Keziah and Tori. Have a great day. Everyone else, have a great afternoon, great evening. Don't forget,
Thank you.
half an hour, Meredith Stoll, the VP for IBM Z Infrastructure, is giving a keynote speech, so please don't miss that. That's on the GSE website in half an hour. I will see you then.